Okay. So blah 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 review blah blah blah. Consider in the space below use the tabular method or distributive method to determine the product for the above expressions. Product means what? Product means I'm multiplying. Product is the answer to a multiplication problem. So that means I'm multiplying. Can somebody get that? Thank you. So right now, I'm just going to do the distributive method on this first one. So distributive method, I'm going to multiply x squared times each term in the second set of parentheses. So x squared times x squared is x to the fourth power. X squared times a 3x, that's a positive 3x cubed. X squared times a negative 1 is negative x squared. Does anybody have any questions on that? All I did was distribute. I took the first term in my binomial and I multiplied it times every other term in my trinomial or in my other set of parentheses. All right. So now I'm going to take the negative 3 and multiply it times all three of these terms. So I've got negative 3 times x squared. That is negative 3x squared. I've got negative 3 times 3x. That's negative 9x. And then negative 3 times a negative 1. When you multiply a negative times a negative, you get a positive, so that's positive 3. So right there, that is the distributive property. I just distributed each of the binomial, the first two terms, to everything else. So now I'm going to take, so I'm going to sort of identify what terms I'm looking at. And I just do that by underlining. Now this is a step that, like I said, you don't have to do. It's just I kind of do it to show. So anyway, 1, 2, 3, 4, because that's the fourth power. 1, 2, 3, because that's the third power. 1, 2, because that's the second. 1, 2, because that's the second, and 1 because that's the first power. So I don't underline the numbers because the numbers aren't any power of x. So I look to see what I have alike. I have this with two underlines and this with two underlines. So those are like terms. So last thing I'm going to do is rewrite my problem with my like terms solved. So I got x to the fourth power plus 3x to the third power, a negative x and a negative 3x. If you're so inclined, a negative 1x. I'm sorry, not x. A negative 1x squared and a negative 3x squared. A negative 1 and a negative 3. If I put those together, what do I get? Negative 4. Does everybody see that? A negative 1 and a negative 3, if you put them together, not multiply, not divide, but if you put them together, which means add or subtract. So in this case, because the signs are the same, they're both negative, I'm adding. So a negative 1 plus a negative 3 is a negative 4. Does anybody have any questions on where we got negative 4 from? Okay, so those are like terms. Then I've got minus 9x plus 3, and I'm done because there's no more like terms. Now that's distributive. Now see, if I wanted to use the box method, I have to realize something, or the tabular method, I have to realize something, that I'm going to have to use a placeholder. Because if I look at this first expression, I've got x to the second power, x to the first power, then no x's. That follows standard form. But if I look at the second expression, I got x to the second power, then a plus 2, no x's. It's missing something. Just like if I said $101, there's no digit in the tens place. So I've got a 1 in the hundreds place and a 1 in the ones place. But there's nothing in the tens place. So in order for me not to get 11, I have to put a 0 in the tens place. So I need to do the same thing here when I think of uh, a polynomial. I've got a times x to the second power plus bx plus c. A, b, and c are just placeholders themselves. They just mean that I've got a number there. It could be 1, it could be 0, it could be 25, it could be negative 32. But honestly, we don't care what the number is. What we care about is that if my highest exponent is 2, then my next highest exponent is 1, and then I have no exponent. So in this second expression here, this second one, there is no bx. So I need to put a placeholder in there. So before, when we looked at a problem like this, we would say, how many boxes should I have? I should say 3 terms in the first one and 2 in the second, so I should have 6. But because I need to put that placeholder in there, like the lady said, I'm going to actually have 9 boxes. So if we initially start with that, and I go x squared minus 4x plus 5, right? But then I need to have that placeholder because I got x squared. I can't just put x to or plus 2. I need to have that placeholder for 0 times x, and then I got my plus 2. So it ends up being 9 boxes. And so now I just multiply. X squared times x squared, that's x to the fourth power. Negative 4x times x to the second power is negative 4x cubed. 5 times x squared is just 5x squared. And then all in the placeholder, they're all zeros because it doesn't matter what I multiply by. If I multiply a 0 in there, it's a 0. So then I got the last stuff. X squared times 2, that's 2x squared. I've got negative 4x times 2, so that's negative 8x. And then finally, I've got plus 5 times plus 2, that's a plus 10. And then I write all my numbers out. So I've got x to the fourth power minus 4x to the third power plus 5x to the second power plus 2x to the second power minus 8x plus 10. And then I do the same things that I did before. I got 1, 2, 3, 4, 1, 2, 3, 1, 2, 1, 2, 1, and none. So I've got 2 terms that are like terms that I need to combine. So that's x to the fourth power minus 4x to the third power plus 5x squared plus 2x squared. What does that give me? What? 7. 7x squared minus 8x plus 10. And we're done. So you can use the tabular method or you can use the distributive method. Did you give me your paper that I asked for? There you go. So next, I've got in the space below, use the polynomial long division, synthetic division, or the reverse tabular method to determine the quotient. Quotient. Quotient is the answer to a division problem, so it means we divide. It means we divide, right? So, and if I look at my divisors, they both have no number in front of x, or the coefficient is 1, and the exponent is 1. So I could use synthetic division for those. I would always suggest you use synthetic division if you get the chance, because frankly, it's easier. So if I'm using synthetic division for a, well, for the first one, what's my a equal? It equals 9, because remember, when I'm looking at my divisor, I'm looking at my divisor. I want it to be in the form of x minus a. So the problem says I have x minus 9. So I've already got the x in the minus part. So a would equal 9. So put 9 right here. And the next thing I need to do is get my coefficients. So my coefficients are what? Like 1, -2, -65, and positive 18. So now, draw my little line. And the first thing I do is bring down the first term. I always bring down the first one. Always bring down the first one. So now, if I've got something under the line, I multiply. I put the answer above the line. When I have two things above the line, I combine them. So 9 times 1 is 9. I've got a -2 and a positive 9. What happens when I put those together? I get positive 7. That's a -2 and a positive 9. The signs are different, so I subtract. 9 minus 2 is 7. The 9 is the biggest term and is positive, so my answer is positive. Now I'll multiply. 9 times 7. What's 9 times 7? 9 times 7. Don't all yell it out at once. That's exactly what it is. It's 63. So now I've got a -65 and a positive 63. So I combine those and get what? I get a -2. My 65 is the biggest number. I subtract and I got 2 left over, but the highest number is negative, so the answer is negative. Then finally, I've got 9 times a -2. That's -18. So I got a positive 18 and a -18. I put those together to get. Now, I put that in my little box because that's my remainder. So once I get my that's my spot for my remainder, I know this is the x to the 0 power, this is x to the 1 power, this is x to the 2 power. And so now let's just write it out. I've got x squared, or 1x squared, plus 7x, second power, first power, minus 2. X to the 0 power means there's no x. There's no remainder, so that's my answer. Now, I can use the tabular method on this. I can use long division on this. But I'll tell you again, I like the synthetic division. So, what's my A for this problem? It's 2. And what are my coefficients? 1, -2, -5, and 6. Bring down the first number. So, what do I do next? 2 times 1 is 2. Put the 2 up here. What happens when I combine those? I get 0. What's 2 times 0? 0. So then I got 0, -5. That's a -5. I've got 2 times -5. -10. And now I've got a positive 6 and a -10. -4. Signs are different means you subtract to keep the sign of the biggest number. 10 is the biggest number and it's negative. So I know I'm getting a negative. 10 minus 6 is 4. So this one has a remainder of 4. So that one has a remainder of 4. I got my x to the 0, x to the 1, x to the 2. So what does that mean? Well, if I just write it out, I've got 1 x to the second power plus 0 x to the first power minus, sorry, let's get that right, minus 5 with a remainder of -4 over, and then I just write whatever I divided by, x minus 2. Well, that is nothing. So I don't need to put it. So I can just say x squared minus 5 minus 4 over x minus 2, and that's my answer. So you can do the synthetic division and get a remainder, or you can do synthetic division and not get a remainder. But I cannot express to you how much easier synthetic division is than the other two methods. Now, if you want me to do one of the other two methods, I can. Does anybody want me to do one of the other two methods? Does anybody want me to do one of the other two methods? Sure. Which one? Because I'm erasing one of them. Which one is erasing? First or second? Okay, first is going bye-bye. But you know what? Before we do that, let's write this right now here. X squared plus 7x minus 2. So that's what we're shooting for, to see if we get that answer. So let's see. Okay. So long division. I've got x minus 9, x to the third power minus 2x squared minus 65x plus 18. Now, the first thing to notice is that there's no placeholders needed because I've got x to the third power as my highest exponent, then I've got x to the second power, x to the first power, then no x's. Now, what I'm trying to do is zero out each column. So when I'm looking at the term I'm dividing into, I want to get a zero there. So the way I get a zero there is by dividing my first term into whatever term I'm looking at. So I only focus on division with the first term. So my first step is division, division or divide. So x can go into x to the third power. Let's write this down here. So I got x to the third power divided by x. That's x times x times x divided by x. Well, an x on top and bottom means they cross out, and I'm left with what? X to the second. So now I'm at the multiply stage. Let's say divide instead of division. Come on. So I divide, and then I multiply. So x to the second power times x should give me the exact same thing that I was looking at. Every time I'm dividing, I should get the exact same thing. Now, the second term doesn't have to be the exact same thing. So I've got x to the second power times a negative 9. So that's negative 9x to the second power. When you multiply a number times a variable, they don't interact. So you just put them next to each other, that they're going to be multiplied eventually. Negative 9 times x squared. So that was the multiply step. You multiply both terms, although you only really divide the first term. All right, next step, we subtract. So subtraction in this realm, I would say, is about changing the signs of both your terms. So that's a positive, it becomes a negative. This is a negative, it becomes a positive. And now I combine. So when I combine right here, I've got x to the third power and negative x to the third power. What do I get? X to the third power and negative x to the third power. What do I get? 0. Don't make it harder than it is. So that first column is zeroed out. Don't need to worry about that first column anymore. So now over here, I have negative 2x to the second power and positive 9x to the second power. What do I get when I combine those? 7x to the second power. And it's positive, so I'm going to put a plus right there. So then my last step is bring down. So I bring down the negative 65x. So now I need to divide again. I'm back to the top. So I've got 7x squared divided by x. Well, that's 7 times x divided by x. I got an x on top and bottom. So what does that leave me with? That leaves me with a positive 7x. So that was the divide. Now I'm going to do the multiply step. I've got 7x times x. Well, if I've got x times x, that's x to the second power. You can also think about this as a 1x. So 1 times 7 is 7. X times X is X to the second power. And now I need to do the second one. I've got 7X times a negative 9. What's that? Negative 63X. Because I'm dealing with 7X. 7X times a negative 9 is negative 63. So now that was the multiplication step. Now I gotta subtract. That's my next step. So when I subtract, I change the signs on both of the terms I just put down there. So that's a negative 7x squared and a positive 63x. So now I combine positive 7x squared and a negative 7x squared gives me what? Oh, 0. So now my second column is zeroed out. Don't need to worry about the second column anymore. But over here, I've got a negative 65x and a positive 63x. So what is that? It's negative 2x. So that's subtraction. Then I do the last step, I bring down. So that's a plus 18. So now I need to get negative 2x. I'm going to divide it by x. So that's a negative 2 times x divided by x. So the x's cancel off, and what do I got left? So I got negative 2. So that's what I multiply by. That's the next step. So negative 2 times x, negative 2x. A negative 2 times a negative 9. A negative 2 times a negative 9. That'd be positive 18. So now that I got that, I'm at the subtraction step, which means I change my signs. So the negative is going to become a positive, and the positive is going to become a negative. And then I combine. Negative 2x and positive 2x gives me what? 0. So now my third column is zeroed out. So now I look at the last thing to see if I have a remainder or not. Ouch. Positive 18 and negative 18 give me what? 0, and I'm done. You don't worry about zeroing out the last column because you can have a remainder, but all the other columns need to be zeroed out. Does anybody have any questions on that? That's long division. Anything else I need to do for division? Does anybody have any questions on long division? Any questions about where I got what? But if you notice, long division and synthetic division, they had the same numbers. I had 1 right here. I end up getting 7 right here. I end up getting negative 2 right there. You know, because I had negative 65 and positive 63. I had negative 2 and positive 9, right? I had a positive 18 and a negative 18. Yes, no? Talking to myself? Okay. So next. What are the first and last terms of the following products? So the first term, all you do is multiply all the first terms. So the first term, first term, first term. So that's x squared times 6x times 2x. So I'll multiply the numbers and I'll multiply the letters. So I've got 6 times 2, that's 12. I have 6, or excuse me, I got x squared times x times x. How many x's is that total? That's 4. If you need to write a 1 when there's no exponent, 2, 3, 4. So that's 12x to the fourth. So now I got the last term. Ow, ow, ow. So the last term, I just multiply the last terms. I got a negative 2, a negative 3, and a positive 7. Negative 2 times a negative 3 times a positive 7. Well, a negative times a negative is a positive. So that's 6. That's 6 times 7. 6 times 7 is what? It's 42. Now I'm expecting y'all to be able to do that. You should be able to say 2 times 3, okay, that's 6. And 6 times 7, you should be able to do that. Whether you're using your fingers and toes or you're using hash marks. I'm expecting you to be able to do that. So that's why I'm not giving out any calculators. So this one, oh no, what am I going to do? Well, this is to the third power, which means it is x minus 4 times x minus 4 times x minus 4. Now we're back in the same boat that we were in before. So I've got the first term. So the first term, I just take the first terms and multiply them. X times x times x, that's what? X to the third. And then I have the last term. So I take the last terms, negative 4 times negative 4 times negative 4. So negative 4 times a negative 4 is a positive 16. Positive 16 times a negative 4 is negative 64. Now, you could also say, well, hey, x minus 4 to the third power, I just take x to the third power, and I just take negative 4 to the third power. You could do that. Thank you. Does anybody got any questions on how you find the first and last terms? Anybody? Questions on first and last terms? All right. Compute the quotients and write in standard form. Well, these these are well, quotients means what? It means divide. It's the answer to a division problem. So it means divide. The thing is, I don't need to actually divide these if I know the identities. So we got the difference of squares, which is, let's take some room for that. So that's x squared minus k squared equals x plus k times x minus k. So let's look and see what we got. Well, I got a square right here. Yes. And right here, I've got x squared right here. Well, part of the clue, if you're not sure, is by looking at what you're dividing by because of the way this problem works. Okay? She's supposed to be, but no. Thank you. Okay. So I've got this problem is x squared minus what squared? 12. If you didn't know, you look down there for the hint. That's 12 squared. And so now I just plug in my identity. Well, I've already got x plus 12. That takes care of that. So then what's left? X minus 12. That's my answer. Over here, I've got x squared minus 169. Oh no, what's 169? If I take it, what's the square? Well, I can look right there. So that's x squared minus 13 squared. X squared minus 13 squared. Follows the identity. The identity says, okay, so if this is x minus 13, which is this one, then my answer would be x plus 13. See how I use the identity to solve the division problem without having to divide? I didn't divide, but I used the identity. Does anybody got any questions on that? All right. Then we have this identity. It's the difference, bless you, of cubes. Cubes means third power. So if I've got x to the third power minus c to the third power, it equals x minus c times x squared plus cx plus c squared. So I'll look at this. I need to write it to look like that. So I got x to the third power minus 8. How can I write x to the third power minus 8 to look like this? Well, I got x to the third power minus, well, there's a hint, it's 2 to the third power. And now well, hey, I already got the x minus 2 part. That's this. So my answer is going to be that part. So it's going to be x to the second power plus cx. Well, my c is 2. So plus 2x. And then I've got c squared. Well, 2 is my c, so that's 2 squared. That's 4. And that's my answer. Now you could divide that out if you wanted to. You need placeholders if you're doing long division, or if you're doing what you call it? Can't even say the name right. Synthetic division. Yeah. Yep. It's one or the other. It's not many problems on there. So anyway, the next one, x to the third power minus 64. So if I want to rewrite it, what do I write it to? X to the third power minus what? 4 to the third power. That's my clue if you're not sure. So now that I got that, I know my c is 4. It's already got x minus c right there. So then my answer is going to be x squared plus c times x, that's 4x, plus c squared. 4 squared is 16. And that's it. Now, next I got perform the indicated operation. So what operation is indicated here? Don't all yell it at once. Addition. I've got one polynomial plus another polynomial. Now these polynomials are not in standard form, okay? There's no rule that says you have to have it in standard form, especially when you're adding. So it's not. But the instructions say write the polynomial in standard form. So I'm expecting your answer to be in standard form. So we're adding. Adding. When you add, you don't have to distribute. This plus sign doesn't change any signs. So adding doesn't change anything. So the next step I'm going to do is I guess I could underline um, what's alike, and then I'm going to write the terms that are alike next to each other. So I've got 2x to the third power plus x to the third power. I've got a negative 6x to the second power plus x to the second power. I've got a negative 7x and a positive 6x. And then let's go rows. Okay. So now I've got a negative 2 and a negative 12. I just wrote exactly what was there. Let's see, green, red, and blue. So now that I got my terms that are alike next to each other, I'm just going to write them, I'm just going to combine them. 2x to the third plus x to the third, or 2x to the third plus 1x to the third is what? Plus 1x to the third is what? 3x to the third. And then I've got a negative 6x squared plus x squared, or negative 6x squared plus 1x squared. Negative 6 and a positive 1. a -6 and a +1. Well, you're adding, but it's a subtraction problem because the signs are different. I'm sorry. So a -6 and a +1, that's a -5x squared. Then we've got -7x plus 6x. I've got a -7 and a +6. -1 or minus x, or -1x if you're so inclined. And then finally, I've got a -2 and a -12. Because the signs are the same, it's an addition problem. -2 and -12. That's -14. Now, if you wanted to, you could rewrite this so it's a little closer together. But I would accept the answer if it was written like that. That's standard form. So now I look down here. The indicated operation is what? It's subtraction. So that means I need to distribute that negative to everything. So you don't distribute a positive. When you're adding, you don't distribute anything. But when you're subtracting, you need to distribute. So the first one is going to stay the same. Just for giggles, though, I'm going to write it in standard form. So I got -x to the third plus 2x squared minus 9x plus 1. And now I'm going to distribute that negative. So that's negative x cubed. And then a negative times a negative is a positive. Because I'm writing it in standard form, I'm jumping to this one. That's going to be plus 3x squared. And then a negative times a positive is a negative. Oops, I wrote a positive, sorry. So that's a negative. And then I've got a negative and a positive. That's a negative again, and still wrote it as positive. So a negative times a +1 is a -1. So see, all the signs changed. I had a negative, I got a negative x to the third power. I got a positive 3x to the second power. I got a -7x, and then I've got a -1. So I wrote that like that, so it's all in standard form. Now, now I'm going to put everything together. I've got a negative x to the third and a negative x to the third. Then I've got a positive 2x squared, and I've got a positive 3x squared. I've got a negative 9x and a negative 7x, and then I've got a +1 and a -1. So what's negative x to the third power minus minus x to the third power? If the signs are the same, it's an addition problem, and you keep the sign. 1 plus 1 is 2, but the sign's negative, so that's -2x to the third. Right here, I've got 2 or positive 2x squared plus 3x squared. That's 5x squared. Then right here, I got a negative 9x and a negative 7x. I've got a negative 9 and a negative 7. The signs are the same, so I add negative 16x. I've got a +1 and a -1. That's 0. So that doesn't really get added on. So I got -2x to the third plus 5x squared minus 16x. And that's it. Does anybody have any questions on that? All right. You looking at the second one or the first one? All right. So the last problem. Perform the indicated operations and write the polynomials in standard form. So if you notice, there's two things going on. This is straight out of lesson 5, putting it all together. So in this case, I got three things going on, not two, excuse me. I've got multiplication. I got to distribute the 2. I've got subtraction. And then I also got FOIL. I got multiplication. I've got 2 polynomials that need to be multiplied. So PEMDAS says I do what first? Well, parentheses, or so I can do that first. Now, because this is a subtraction problem, I can multiply the first thing, I can multiply the second thing, then subtract, and it's okay. I don't have to worry about doing this first and then do that. So I'm going to distribute the 2. So that's 2x to the second power minus 10x plus 8. Does everybody follow? Just multiplied everything by 2. So put some parentheses around that and say minus. And now I got to do FOIL to multiply this out. So I got first, that's x squared, x times x. Then I got outer, that's x times 2, so that's plus 2x. And then I've got inner, which is 3 times x, that's plus 3x. And then I've got last, 3 times 2, that's 6. And so I just want to add my like terms. So I'm going to have 2x squared minus 10x plus 8 minus x squared. That becomes 5x. So plus 5x plus 6. Does anybody have any questions on what I did? I multiplied the first set of stuff. I multiplied the second set of stuff. Now, there were 2 different methods. One was just distributive. The other one was FOIL. Or you could say distributive if you want, because FOIL is just a distributive when you're using binomials. So does anybody got any questions on what I did so far? All right, well, we got to keep going because we're not done. Next, I need to distribute the negative because we're subtracting. So I'm going to have 2x squared minus 10x plus 8. And a negative times x squared is a negative x squared. A negative times a 5x is a negative 5x. And then a negative times 6 is a negative 6. So now I've got x squared, x squared. I've got negative 10x, negative 5x. Oops, sorry, got a little ahead of myself. And then I've got 8 and negative 6. So now I just combine my like terms. 2x squared minus x squared. Negative 10x minus 5x plus 8 minus 6. So what's 2x squared minus x squared? It's just 1x squared. 2 minus 1, that's x squared. I've got negative 10x minus 5x. What's that? Negative 15. If the signs are the same, you add and you keep the sign. So 10 and 15 is, or excuse me, 10 and 5 is 15. Both of the signs are negative, so that's negative 15x. And then I've got 8 minus 6. 8 is the biggest. The signs are different, so I keep the sign of the 8, so it's plus 2. And that's the whole thing. X squared minus 15x plus 2. So in that problem, I had 3 things that I had to do. I had to multiply the first set. I had to multiply the second set. Then I subtracted. In the second problem, I've got something taken to the second power plus something taken to the second power. So I need to multiply both of those. So something taken to the second power is x plus 3 times x plus 3. And then that's all plus x plus 4 times x plus 4. So I could do FOIL or the box method, whichever you prefer. But because we're running out of time, I'm going to try to jet through this. That's x squared plus 6x plus 9. I got x times x. I got x times 3. I got 3 times x. And then I got 3 times 3. Well, the 3x's are in the middle. I add them together to get 6x. And then something similar happens over here. I got x squared, right? I got plus 8x plus 16. 4 times 4 is 16. 3 times 3 is 9. 4x plus 4x is 8x. That's how I get my middle term. You want me to show you where I got the middle term from? Okay, let's see. I should have enough time to do that. So let's do some FOIL instead. So x times x, that's my FOIL, that's my f. That's x squared. Then my outer terms are x times 3, so that's plus 3x. Then my inner terms are 3 times x, so that's plus 3x. And then my last terms are 3 and 3, that's plus 3 times plus 3, that's 9. So notice that my middle terms, they're like terms, so I can combine them. 3x plus 3x is 6x. Like I said, I just know that from practicing this stuff a bunch of times. So the same thing happens here. I got the first term. Matter of fact, let's do a different color. So I got the first term. That's x times x. So that's x squared. I got the outer terms. That's 4 times x. That's 4x. Then I got the inner terms. That's 4 times x. That's another 4x. And then I've got the last terms. 4 times 4, that's 16. Well, those are like terms. I can combine them. So I get x squared plus 8x plus 16. And those are both being added. So now I just combine my like terms. So let's go purple. So I've got x squared and x squared. I've got x and I've got x, and then I've got two numbers. So x squared plus x squared plus 6x plus 8x plus 9 plus 16. What's x squared plus x squared? That's 2x squared. What's 6x plus 8x? That's 14x. And then what's 9 plus 16? It's 25. Done. That's everything. And I am done recording unless does anybody have any questions before I stop? Okay. Stop.